Cauchy Riemann equations. If f of z equal to uxy plus iota vxy is differentiable function at z equal to x plus iota y, then del u by del x equal to del v by del y and del u by del y equal to minus del v del x. So these are the Cauchy Riemann equations which we are going to prove, and it is given that fz is your differentiable function. So we just need to apply the definition for the differentiability for fz. So let's start with the proof. Now as fz is differentiable at z, then f dash z is equal to, so this is limit, I'm taking h which is tending to 0 along the real axis, f of z plus h minus f of z divided by h. Yes, where h is tending to 0 along the real axis. Then in the next time we take that h tends to 0 along the imaginary axis. So first we are taking h is tending to 0 along the real axis. So this is further equal to limit h tending to 0 f of, writing the value of z, that is x plus iota y plus h minus f of x plus iota y divided by h, and then limit h tending to 0, separating the real and imaginary parts, and this is f of x plus iota y divided by h. Now it is given that f of z is uxy plus iota vxy. I'm going to apply this now. So this is equal to limit h tending to 0, u, what is the real part? It is x plus h, comma, the imaginary part, plus iota v x plus h, comma, y, minus, for f of x plus iota y we write, it is also in terms of u plus iota v. So this is uxy plus iota vxy divided by h, taking the real parts together and imaginary parts together. So this is ux plus h, comma, y minus uxy, taking these two together, plus iota vx plus h, comma, y minus vxy. Yes, divided by h. And now taking the limits on the first term and the second term separately. So this is equal to limit h tends to 0 on the first term plus iota limit h tends to 0 on the second term. Because we have taken h tending to 0 along the real axis, so this becomes del u by del x, and this is nothing but your del v by del x, the definition, right? So this is equal to del u by del x plus iota del v by del x, and on the left hand side we are having f dash z. Please mark this as 1, the first result. And now we are going to take h tending to 0 along the imaginary axis. So let h approaches to 0 along imaginary axis. Then for h equal to iota k, where k is real, we have f dash z to be equal to limit. This time we are writing k tending to 0, and the definition f of z plus, instead of h we are using iota k. So this is iota k minus f of z divided by, again we are writing instead of h as iota k. So this is equal to limit k tending to 0, writing the value of z, that is x plus iota y plus iota k minus f of x plus iota y divided by iota k, and then separating the real and imaginary parts together. This is iota y plus k, right? And now writing this function in terms of u and v, that is ux, the imaginary part, y plus k, plus iota v x, comma, y plus k, right? And writing this as uxy plus iota vxy. So this is limit k tending to 0, collecting the real and imaginary parts separately. So this is uxy plus k minus uxy divided by iota k minus iota vxy plus k minus vxy, and is divided by iota k. This iota is cancelled out with this, and now taking this limit inside to the first term and also to the second term. So this is equal to limit k tending to 0 uxy plus k minus uxy divided by iota k plus limit k is tending to 0 vxy plus k minus vxy divided by k. So this is a definition for del u by del y, and this is the definition for del v by del y. So this is equal to, I'm taking 1 by iota outside and writing this as del u by del y plus del v by del y. And on the left hand side we have f dash z. If I multiply the numerator and denominator with iota, I get this to be iota square, which is negative 1. So this becomes negative iota. Is it okay? Fine. Please mark this as 2. So from 1 and 2 we get f dash z to be equal to del u by del x plus iota del v by del x, and f dash z equal to minus iota del u by del y plus del v by del y. So these two are equal. So this implies del u by del x plus iota del v by del x is equal to, I'm equating this to this, minus iota del u by del y plus del v by del y. Comparing the real and imaginary parts, we get del u by del x to be equal to del v by del y, and del v by del x is equal to negative del u by del y. You can also shift this negative sign to this. It is your choice. So these are the Cauchy Riemann equations. Alright, thank you. Stay blessed.